Welcome to our last webinar of the year. Today we'll be focusing on where the data comes from, so looking at data source and quality within PK. My name is Gabriella Hooper. I'm head of marketing here at PK. And Tim Grant, who I'm sure you're all familiar with, will be leading the webinar. So to you, Tim.
Thanks, Gab. So today probably one of the most common questions we get is what's sitting behind PK? Where does the data come from? How good is it? How do we check its quality? How do we know that it's right? And unfortunately, we always have to say that we definitely know it's not true and correct representation of reality, but it is a data set that is useful, hopefully. So we'll go, I'll just share my screen, and please interrupt at any point during if you've got a question, want to make a comment. So we're going to go through in sort of reflecting on where the data comes from. I'm actually going to go back and describe a little bit of what data used to look like back in the early days, which sort of gives us a bit of the evolution of how we get to the data we've got today and why maybe it's a little bit variable, but way better than it once was. So let's jump in. So LCA is now 54 years old, starting in 1969. We had our 50th anniversary a few years ago. And it is becoming a bit more of a mature science. A lot of the development of LCA methods were in the 1980s, and a lot of LCA data was actually developed in the 1990s and coming from sort of factory reports and things that were done in the year. As evolved, it is explicitly about environmental sustainability rather than sort of social sustainability at this point, although that is evolving as a branch in itself. It is about supply chains, relates to cradle to grave assessment, and still right back from those 1990s, we still have the overarching standards of 1440, 44, which really guide the development of LCA, and the rules around how we make claims and things today are still very strongly linked to those standards. The early data sets from LCA were absolutely horrible. When I started, we had not a central database. We had just like four or five bit databases, all developed on a different basis, largely project-based, that was sort of floating around in SimaPro, which was the LCA sort of tool that we still use underpinning PK. We had something from Procter & Gamble called Vandenberg and Jurgens, which was just sort of floating there, and you can never actually find the original document. I've searched and searched. I find some things that they produced, but not the actual data set documentation. There was the Boval packaging data set from the Swiss government agency. For many years, I thought Boval was some professor somewhere in Europe, and in fact was actually a government agency. And then the Dutch had little data projects. The University of Amsterdam did some things in the building domain and had a little data set. IDMAT from Delft University had a data set based on sort of industrial design type materials, but really simple. Just a lot of the data set was just based on stoichiometry. And then there was slightly later than that, I suppose the first beginnings of a detailed data set was from called the ETH ESU database, which was again from a Swiss agency. And when we look at what that data looked like, this is a screenshot from SimaPro software from back at around that time. And, the whole production of iron was simplified to 4 inputs of materials and 6 emissions. So very, very simple. And for some, reason, 1 kilogram of sinter came in and 1 kilogram of iron went out, which is very convenient. And so very basic data sets. And this was still sort of being used in, I'd say, the year 2000 into early 2000s, this was the quality of data that we had. If you drew a network diagram, or like a diagram of all the processes, this is the entire life cycle of the production of steel, from the Vandenberg-Jurgens data set, and that's every process that's in it. And you can see the very simple databases, mostly covering just the priority pollutants as a in terms of impact categories. So that was the case right up until the advent of the Ecoinvent database, which was one of the first major times when someone sat down and deliberately started to think about building a coordinated database from multiple sources. And it came about because, from what I can understand and discussions and reading through it, each of the Swiss institutes, remember Switzerland were very important in the early development of LCA methods and data, and the Boval data set came from there, and the ETH data sets were coming from there. So there was competing data sets, and so they had a project where they sat down from these 5 institutes covering agriculture, energy, material science, were coordinated to actually produce a purpose-built database that wasn't just project-based, answering 1 or 2 questions, but okay, we've got lots of questions that we want to answer. How do we actually build a database? And so we established a set of rules for the database, what flows should be included, how flows should be linked, how flows should be named. They built a data and documentation framework, and so really started to fill out the documentation processes, consistent rules for calculations, and also some of the first concepts of regionalizing data sets, where you actually nominate that you maybe have 2 data sets for a process that come from different regions, which was still pretty new. At the time, you were happy to get 1 process for steel rather than actually go and ask, be choosing between 3 or 4 different processes from different regions. I remember at the time there was a lot of discussion around data quality guidelines and how you would assess data quality and to evaluate different data quality from different data sets that you were going to choose from. However, the idea of choosing from different data sets was foreign in a way, because you rarely had more than one option. So in this modern database, we look at a process in SimaPro of what the modern day Ecoinvent looks like. We see a lot more flows, a lot more documentation of what's happening on each flow line. So here we've got, for the output flow of PET amorphous, it's rest of world region. We get some data about the properties of that material. We start to get flows, so water flows that are differentiated about how they're being used, differentiated by region. And we have things like capital equipment starting to be built into the databases. So if you produce chemicals, you must have a chemicals factory. And so there's a model for the factory that supplies chemicals. And then we have electricity regionalized across, I think, 180 countries or something like that in Ecoinvent currently. So this is a major shift, and all the processes are using the same codes, the same description around uncertainty values. They're using the regionalization and the like. And so what it looks like when you draw a diagram of it, this is at about a cutoff of 2.5% greenhouse gas emissions. You can see what processes are going in, and so we've got wiring boards going into control units, going into buildings, buildings going into factories, factories going into the production of PET. I think this was actually not showing greenhouse gas emissions. I think looking at the processes, this is showing the demand for minerals, abiotic depletion of minerals. So it gives you a very sort of skewed group of inputs from copper, cobalt, things like that, which are all contributing to the total demand for minerals within the polyethylene supply chain. If you drop the cutoff down to 1%, you see more processes. If we drop it to 0.1%, we start seeing hundreds of processes all connecting from different regions and different technologies. So that's sort of the quantum difference, so as it came about when we, as we moved from, say, the year 2000 through to 2010, and that has been getting built on right through the 2010 through to today, expanding that database. The data that is embedded in Ecoinvent, where does it come from and how is it maintained? So there is within Ecoinvent, there is a periodic updates to data that has been aging. So there is a sort of review, and always on their agenda, will be that there are certain data sets that haven't been updated for many years, and maybe the system has been changing significantly. Up until now, things like the mining of sand and gravels and things, some data sets are just very, very old, and they never represent a large part of any single life cycle assessment, except in and of themselves. And so maybe they often will be left behind in terms of being updated. But there is a process. They updated a couple of years ago all of the data around oil and gas production, because new information came about relating to the fugitive and diffuse emissions of methanes around gas and oil fields. There's been some new data on informal practices, waste streaming practices and things like that that have been undertaken. Then there is like specific funded projects where there is a associated activity, something like the World Food Database, initiated by major group of international consortia of food companies that funded the development of that database, and all of that data was originally shared with the collaborators of that project, but then had a contractual obligation to deliver that data to the rest of the world through the Ecoinvent database. And similar projects for the practices from informal waste streaming practices, annual electricity updates that happen every year. There are then, so these are generally all Ecoinvent activities. And then there are groups of data suppliers, developers, practitioners outside of Ecoinvent that collaborate with them to put data in. There's SICV in Brazil, who are a national inventory project, CIRAG in Quebec, AgriBelays in France, and even in Australia, Lifecycle submits data on behalf of Australian agriculture at the moment into Ecoinvent as it's contributing to its development. What that's come to now in the current version of Ecoinvent, version 3.9, which is about to be superseded they say by the end of November, by version 3.10. We have around 24,000 processes. 8,000 of those are market mixes, and so that's the mix of producers. So if it's electricity, it'll be the mix of all different grid processes. If it's soybeans, it'll be production of soybeans in India, China, Brazil, the US and Europe, and then it'll give you a market mix if you so need that. And then there are 16,000 actual production processes there, which produce are the way in which inputs are transformed to outputs. The distribution of processes has changed significantly. Originally the Swiss processes, there were more than 4,000. They've actually dropped down, so obviously they're starting to remove processes that were supposedly just Swiss-based, and increasing the number of global processes on the basis that many valuable products don't have a local market. There is no, you can pretend there's a local Swiss market for the supply of electronics, but in reality, electronics operates as a global market, and therefore, and production is centered in Asia, and therefore there's no point having a Swiss process thing. So I think they've been reducing the reliance on European and Swiss data, increasing the proportions of Chinese and Indian data. The projects in South Africa and Quebec have sort of paid off with a lot of processes, and will this Australian one should be up over 140 processes by the time we get to the next version. A little bit short on processes in the US, which is probably a little bit concerning. Sort of see this a little bit about the situation there from a data development point of view. So that's within that then. So what sorts of flows are included these days within the Ecoinvent database? We have land use entries. So there is occupation and transformation for any process that uses land, be that a factory, a farm, a road, any activity will have a full characterization of the land use. And these days that land use will be regionalized by country. So you will differentiate between land use in different countries so that you can then infer different impacts from different stresses. Water use is similarly regionalized by country, so that the relative water stress within a country can be accounted for in the inventory. And we currently have a problem in our regionalized water stress indicator in PK, which was caused by the inclusion of water released to, I think Ecoinvent in version 3.9 added a new flow for water released to oceans, fresh water released to oceans, and the impact methods picked it up as being a return to the environment. And it is returned to the environment, but it's not actually functionally valuable to the process, because you put fresh water in the ocean, essentially no longer fresh water. And so that's thrown our water inventory out. We've fixed it in our main data set, but we haven't got a chance to upload that into PK yet. And we also have regionalized emissions. So sulfur oxides, nitrogen oxides, particulate matters are all regionalized because they have different effects in different countries relating to how the data, how the local environments, how sensitive the local environments are, population pressure, exposure pathways and things are all taken into account in those regionalized data. So that's a lot about what Ecoinvent do, and that isn't us, but they are an important part. And I would say about 2/3 of our data would be Ecoinvent, almost pure Ecoinvent data, and about 1/3 of the data is data that we generate ourselves, specific processes that aren't available there that we build on top of the database. And so firstly, what we do for the generation of data sets, we regionalize the data. So within the Ecoinvent system, they have regionalization, and they have all the countries for, as I think for electricity, they have 180 countries or thereabouts. So there are lots of regions in there for that. But when it comes to material production, conversions, manufacturing processes, chemicals, typically there are only maybe between 2 and 5 regions for any particular commodity, with the exception of energy systems. And they generally look like you have maybe a European process and a rest of world process. What's not European? If you're lucky, maybe in some of the agricultural commodities or cotton, you'll have Indian cotton, Chinese cotton, US cotton, and then rest of world cotton. So for our users, we want a bit better regionalization. If someone is determining that something is actually made in their country, they want the model to represent, at least be a good representation of production in the country of origin. So we undertake the regionalization on 54 regions, and we do that by going 1 or 2 layers deep in the supply chain. So we don't want to over-regionalize and pretend that just because you have a starch-based biopolymer produced in a country, that every contributing process to that material will come from within that country. So what we do is we take the main thematic part of the process. So if it's polyethylene, we'd take the polymerization of ethylene and the production of ethylene from underlying fuel sources and say they are deemed to be in the country where you say that they're made. And below the ethylene process, the supply of gas and oil and chemicals are deemed to come from the global market. So we end up in the global market 1 or 2 layers into the supply chain. We also localize the water in each process for the region you're in, those key emissions data of SOx, NOx, particulate matter, and we will regionalize the land transformation. It's not currently regionalized, but that will be regionalized before we release Eco and PIQET 5. Yeah, and we may see that generally that regionalization will increase over time. There is a regionalized model for eutrophication now, which is quite important, I think. Nutrient enrichment of waterways is quite site-specific and country-specific, and I think that will be added also in PIQET 5. The other things that we adjust in the local domain, we adjust for freight efficiencies, which we have. You joined the webinar last month. I think we talked about freight efficiencies, and we have those by region. Any behaviours of landfill, is landfill gas likely to be captured? How do landfills operate? Obviously, we don't get this data for every region, but for any region where we can get it, we will add it. If not, we have a default for regions where we can't get information. And then we collect data on waste management processes that feed into the end of life of processes. So that's our regionalization. We also remodel the end of life. So there are, and it's probably a topic for next year, a complicated set of rules about how we deal with recycling and recycling credits in LCA, between recycled content coming in and recycling at end of life. The Ecoinvent database has its own rules, has some flexibility, but it's not suitable directly for use in PIQET. So we have to go in and engineer what a recycled material looks like, what recycling at end of life looks like, and then work out how to make sure we're not double counting across those. And then we add a series of additional materials, technologies, conversion processes, on top of the processes that are readily available within Ecoinvent. What that looks like as an overall data model is we have our beginning data sets being regionalized within SimaPro LCA software, which is our underlying very detailed LCA tool, which is fun to use for us, but generally is a lot of hard work. We then build up our indicator data sets, run that model to actually build up what you might think of as emission factors per unit production that get uploaded into PIQET. We add the waste management defaults, and that whole data file comes up into the application where you really build up your scenarios and projects, and then we output the results to the different formats. So that's the overall picture of the data system and their interactions. We also do some of our indicators don't come from that LCA data. So we have a group of packaging indicators. So the life cycle assessment indicators, carbon footprints, water footprints, all come from the LCA data and are pretty much direct calculations from there. But packaging indicators from the Global Packaging Protocol, the product to packaging ratios, the material to landfill, material to recycling, recycled content, they're all calculated within the PIQET tool based on the data you enter and the properties and materials you use. And then we have our material circularity indicators, renewable content circularity index, which again are a mix of the data you enter about how much recycled material you use, whether you've got reuse loops, what recycling is happening at the end of life, and data about the recycling efficiency. So we have to program into it when you're recycling paper, it's not 100% efficient. You've got maybe a 10% loss of fibre through that process, which needs to be counted into the material circularity index. And the litter indicators at the moment are also manually calculated in a way in SimaPro, in PK. We have damage factors which are linked to a few things. If you send material to landfill, you can have a default leakage percentage from landfill. Because essentially when you go to look at litter, no one ever says, oh yes, and we made this product and then it gets littered. Everyone just sort of assumes it doesn't. So we model that the waste management system, even when it's operating well, has some leakage, and so those default leakage values sit in PK and are actually editable by organisation, but are available there. And then you can also model that something did go to litter or to stormwater, in which case then it's considered that material has been littered. So all those data are not calculated out of Ecoinvent or any of that database. They're properties of the materials loaded up into PK. And then similarly, the circularity index is evaluating your use, reuse, virgin feedstock, and the like. So quality assurance, how is quality assurance and quality of data managed across the process? Oops. And I suppose there's two parts to this: what happens in the data before we get it, and what happens in the data after we get it with what we do. So before we get it, I had a general idea of what happened at Ecoinvent, but we've had much deeper insights since we've been recently adding data to the PK data, to the Germany databases, to the Ecoinvent database as part of a separate project that we've had here in Australia on our agricultural data. And it was a long sort of 4-month process. We started in February this year, and we've only really just completed it 2 weeks ago. Uploading data into their system, it being checked that it matches in all the nomenclature so it all gets recognised in the right way. And then there are a series of reviews, a general topic editor review from the industry of interest, reviews from so geographical editors, who people are looking at the geography of the data and is it properly recognised and regionalised. Life cycle impact assessment editors, so people who come and look and say, well, we had an example where the nitrogen from agriculture, we just had it going to water, and they require that it's differentiated whether it's being leached to water or to surface water or groundwater, and we have to build in those additional data things. Then after all those reviews and we're all happy with it and we've gone backwards and forwards, it then gets sent out to an external reviewer outside of Ecoinvent to be examined for consistency, quality with other processes. So quite a rigorous process that goes on. So that happens at the Ecoinvent level. Then within PK, we build on top of that data with all the things that we do, and we produce the regionalization. And we have a series of checks that we undertake. We generally compare all the materials to what they look like in the previous version. We compare the indicator results against one another across all processes. And generally, you expect them to have some particular order. You would expect, electronics and things to be at the top, maybe metals and polymers, and then you get down to simpler processes, simpler materials, and you can examine and make sure that if there are any outliers or modeling errors that would stand out in that process. We check whether the recycling processes make sure they don't generate more benefit than is actually put into the original material that's being recycled. and we do a series of mass and energy balance checks within processes. We have had the data critically reviewed previously and certified under PAS 2050, the European standard, back in PK3, and but that was done against the PAS standard for a very specific purpose. What our process is now is that we are going through the development of PK5, where we are aiming to enable people to do an ISO 14044 certified LCA report produced directly out of PK for third-party review. And so that third-party review will both review what you've put into PK in terms of the modelling, your choices of materials to represent what you're representing, maybe your choice of end-of-life data, but we'll also review the data sets that sit behind that in our in the database and how they're structured. And so we're in the process of developing a large documentation around each and every individual process, how it's been modified, what's been regionalized, where did the original data come from. So that'll be all there to support that third-party review process. And the other informal review process we have our users who are always on the lookout for things that don't make sense within the tool, feeding back results and queries and questions about data, and we can then go in and see whether the counterintuitive result is genuine counterintuitive result that maybe is a surprise but is a real thing, or whether it is a modeling artifact, or whether there's actually an error or within the database. So that's the a little bit on the process of where the data comes from, how we modify it, and we are at a time now where we really have increasingly more and more data coming onto the market. So it's an exciting time to be doing life cycle assessment and building tools and developing data. We have more data than we've ever had, and that's only increasing. Still not a lot of data that is produced and made available at the appropriate level of disaggregation. Normally it's a few greenhouse gas results, some simplified data bits, maybe a graph or two that you have to work with. Whenever we are putting data into the PK, we're making sure that it fits in with this overall, if I go back to this sort of system here, that we're inserting it into this matrix so that it is consistent with all the other processes. So it has a factory that's building it, that it uses energy systems that are comparable to the final process. So thanks. Any questions or comments, queries?
So you're not using SimaPro data these days, Tim?
All of that data is modelled in SimaPro.
Yep.
So it still comes through SimaPro, but it comes before it comes from Ecoinvent, and so SimaPro does have other data sets that it that are available and you can use, but we don't take any data directly from other data sets. If we collect data from the US data set or from AgroBelaze or from any of them, we take the bits that are of interest to us and we insert it into that Ecoinvent matrix within SimaPro. So all the regionalization things are done in SimaPro, where we have a bunch of people here who are very clever at making it do funky things and doing that sort of extended regionalized calculations.
That complex flow chart, which is the Ecoinvent, as you get data in from other LCAs, you're able to compare that data, and then if it's updated and things like that, you can insert that to give us the latest information. How do you keep track of that? That must be due in terms of the changes, particularly changing the Ecoinvent data.
Yeah, so there are a couple of things in there. One is how do we keep track of what we're putting in, and I suppose over the last 3 or 4 years, whenever we add data, we go through some quite detailed documentation of what we've done. The problem is when you've got a sort of legacy issue of, when there was lots of data produced back in the day and put in, it doesn't have a complete documentation around it because it was in the earlier versions of the tool. And, often when people are building the first concept version, the documentation is sometimes lacking. So we've sort of got to backtrack and, like a bit like Ecoinvent, we need to go back and look at our legacy issues of how old is particular data sets. Do we have appropriate documentation of the way in which it's been regionalized and modified? Is it accurate is the description and the metadata about it accurate to the process? So we're working through that process on our own data and the data we develop and how we interpret the Ecoinvent data. The other thing is managing. Every year we get a new set of Ecoinvent data which changes. There's 24,000 processes and every process changes, so a little bit, some more than others. Sometimes the names also change, sometimes the regionalization increases, sometimes it decreases, and so we have to re-merge that Ecoinvent data set generally during February, getting it into PK so we can take advantage of all the updated data. And it's a model of Ecoinvent, like any of these models, is a model of the global economy, and and so you want it to be moving and changing, and that's why we do LCA, to advise people on product choices and process choices, and so the world gets better. But yeah, that is a significant task and can lead to some unexpected changes sometimes because processes are changing. Like after Fukushima, the footprints in Japan went up enormously. We see footprints of electricity in Germany increasing its footprint because of moving out of nuclear. We see a lot of other renewables coming in. And then we get things like this water regionalization thing, which has thrown our water thing out. So it's a process to do that. So we try to only do that once a year as a major, because it's a major update. So, but yeah, as we go along, we find little issues that we'll fix during the year.
With any projects that we've had in there before, and some of with the updates of PK, does that automatically change data that we've done, or would we need to rerun the data of a project to update that?
Yeah, we don't keep a legacy. We generally, when we do a data update, we provide the legacy version for a few months for checking and verifying the new data set. So we'll put that on app2.pk, so people can go and see if they're wondering why things are, want to check whether it's their data has moved and why has it moved and what did it look like before. So we do that, but we generally leave that for about 3 months. And then once the new data is settled, that's what people work with. And so we could, some databases hold full legacy versions of all the prior updates that they've ever done, and you can sort of revert back to some earlier point in time. At least at the moment, up until this point, PK is about designing better packaging. And so I think to overthink it and think that the values that you had are extremely precious and very, very accurate, and that shift is like now that they're wrong, is the wrong way to be thinking about the data. The data, you really should be looking just at the first number, not anything past that, the first significant figure, looking at the direction of the results, and that's what matters. Yeah, so rather than having this really ordered sort of
a
focus.
number, yeah. So
yeah,
in terms of, I was comparing a PET bottle with an aluminium can, and we wouldn't expect the data to have changed so much that all of a sudden the aluminium can's got a better footprint than a PET bottle type data.
Yeah, exactly. Until it does, and then so we're probably very close to bringing on green aluminium with has 100% renewables in the electrolysis process. That will be a separate product, not the standard product, but as that comes on, its footprint will radically change, while the footprint of a plastic component won't change so much, because refineries, probably aren't going to get that much smarter than what they are now. So for the most part, you're right, things should move around a little bit. The non-greenhouse indicators, things like water data and other things, are already usually pretty highly variable at a manufacturing level. Some people have a closed water system. Some pulp mills don't use any water. Others, if you're in an area where you don't have any water stress and water's cheap, you're likely to be using significantly more water. And so there's a lot more variable than, say, the climate change results, which are much more thermodynamically connected to the chemistry of the process. You only need so much fuel to burn something or other. So you will find that the non-greenhouse gas indicators, some of them will jump around from version to version, because they're affected by much more variable processes in the background.
Okay. Thank you.
All right. Well, thank you, Tim. I found that really useful, and I hope everyone else did. I'll share the webinar recording at the end of the week. As usual, if you have any questions, send them through. The next webinar will be mid-February next year, just so we can get PK5 cracking and in a good spot to show you all. But yeah, hope you have a lovely rest of your day or evening.